So hey everyone, welcome to the New York Summit. I am Rudy Chetty, a Principal Solutions Architect for AWS. And I've got Brent Brunel, who's a Director of Edge Controls, who's going to co-present today in this fun IoT presentation. So let's dive into it. Whoops. So this is the agenda. You can see we're going through what is IoT. We'll dive into AWS IoT itself, the services portfolio, and then we'll bring up Brent for a customer spotlight. So before we can dive into IoT itself, we got to define, well, what is a thing? Well, think of a thing as a device. It has one or more sensors. It could have none. It has limited resources. That's CPU, RAM, memory, everything, or storage, I should say. Then again, a cell phone or a smartphone can be considered an IoT device as well. You usually have these devices in operational isolation. That means that they interact or they kind of stay in their channel. They collect information. They're kind of fairly disconnected. The beauty of it comes in is that if the firmware on that device has connectivity to the cloud. And I like to give an example of one which is kind of amusing but kind of not, is a toothbrush. That could be considered an IoT device. It links via a Bluetooth app to your smartphone. In fact, the use case I can think of here is maybe you're a dad or mom on the other side of the world, and your child is brushing their teeth, and they're doing it incorrectly. You get a notification on your app that says, hey, got to tell the child how to brush their teeth correctly. Now, if we take all of these together, it's what we describe as the Internet of Things. It's all these devices coming together and sending data to the cloud where we can perform this kind of meaningful intelligence on it. Now, AWS's concept of IoT is split into three regions. The first one being the things. These are the devices that can sense and act. Maybe they have a temperature sensor, maybe humidity. From there, you output to the cloud, where you're going to take advantage of the processing power that's involved. Because, like we said, the devices themselves have limited capacity. And once all that lovely information is up in the cloud, this is where we perform intelligence on it. Whether it's analytics, maybe reactive, proactive alerts, ones where, we can actually do something with that data once it's put to the cloud. Now, if we expand this out, you can see that we've got, different areas that we're going to dive into. On the left, we've got the things. On the right, we've got the secure connectivity, which is one of our services. And on the left, again, we've got the gateway and endpoints. It's stuff that we offer in the AWS services portfolio. And as we keep expanding, you'll see several ones that we have here with fleet onboarding, audit protection, even analytics. We want to make it so that when you utilize AWS IoT's ecosystem, it's all-encompassing. So let's dive into each one of these. The first one being device connectivity, because you want to know how to connect all your lovely IoT devices. This is a service, whoops, looks like this clicker is skipping ahead. This is a service called the AWS IoT Core. And you can see the plethora of features that we have. But as I mentioned, let's dive a bit deeper. So the first one we're going to tackle is the identity service. Now, this service allows all your devices to actually connect. You can do this, whoops, is this clicking through? Oh, you can do this via certificates. These are AWS-issued certificates. You can even do it with your own. That's the flexibility that we're bringing to the platform. These are automatically provisioned, or you can do that with just-in-time registration. What does that mean? Well, automatically is that you're actually provisioning them at the factory so that when the customer turns it on, or turns that device on, it's actually provisioned already. Or just-in-time registration, where when the device connects, that's when it registers. It's kind of again, the flexibility we're offering. You can even install them yourself in a manual approach. The IAM and AWS IoT policies that come into play, IAM being identity and access management, it's the way that you access your AWS services. Now, if we overlay that onto AWS IoT, those policies themselves are linked to your devices. And it tells the device what it has access to in your AWS ecosystem. Hence the linkage. Amazon Cognito is a way that you can also link your devices to be authorized. It's one of our services that are very useful for mobile, even desktop, and it allows you to offload the authentication authorization away from IAM. So it's this logical separation of IAM being your infrastructure layer and Cognito being your user layer with regards to authentication and authorization. You can even federate the identities. I mean, I think that's pretty cool. If you have an existing, I'd say a data store with all your users, you can federate to that. And this is how you connect your devices up. Now, once they've connected, they initiate what they call a long-lived connection through device gateway. That's bidirectional, so you can communicate to the cloud. Likewise, the cloud can send messages down to your device. These are through several different mechanisms. MQTT, message queue transport telemetry. It's a very low payload protocol. So for IoT devices, it makes a lot of sense. Standard WebSockets or HTTP if your devices don't support something like MQTT. As we've mentioned before, these certificates, being SIG-v4, signature version 4, X509, and the token-based authentication can be done via a custom authorizer. So if you actually want to do custom authentication, write an authorizer, plug it in, there you go. We support TLS 1.2. This is kind of important because, some devices use 1.1, and that's not, we'd rather support the most, the latest version of the TLS protocol being 1.2 in this case. And I will say that if you have devices that are connecting over TLS 1.1, it's kind of time to upgrade or migrate, that being a best practice. Once we've taken these devices, connected to the cloud, we're going through the gateway, essentially they're sending messages upwards to the cloud, and we want to broker them or move them to different services. This is where the message broker comes in. It operates on a publish-subscribe model. Well, what does that mean? Well, it means that you can publish once and have multiple subscribers. That way, you don't have to keep subscribing per device. You could actually publish the info from that device or several thousand and have just as many subscribers pulling the messages in. The quality of service, or QoS, that we support is 0 and 1. We don't support 2. 0 being deliver it at least once is 1, 0 is most once, and 2 is exactly once. And the reason we don't is because, again, it's a custom version of the MQTT protocol that we're supporting. So if there's any features that you might be used to, make sure you check our documentation to say, hey, these might not be supported. I will say, however, one of the slides coming up, we do have a solution for not supporting QoS 2. The publish and subscribe, they work on topics. Now, when you create a device, you actually get reserved topics. Ooh, this clicker is very... You actually get reserved topics that start with that prefix. The $AWS / well, actually, the /hash is a wildcard. So think of using wildcards in the sense of, well, we've got a building. It's got light bulbs on floor 5. I want to subscribe to all those light bulbs. Well, you could subscribe using a wildcard, or you could go in there and subscribe to each one individually. You can see one method being better than the other, or more easy, I should say. But like I said, you have all these topics that come when you provision a device. However, you are more than welcome to actually go in and create your own topic and subscribe to those. Use it as the way to actually get all the info from the device versus querying the device directly. Now, once you've got all the messages, they're coming through the message broker, we want to kind of move it between services, as we mentioned. This is where the rules engine comes in. And what is the rules engine? Well, it's the way of routing the devices based on a rule that you create. So there's 2 parts to it. There's the rule, which we can see is up on the screen, and it uses a very familiar query language, something that most people are used to. It uses a SQL-esque language. So you can run SQL queries, in this case, to actually get the temperature if it's greater than 35. I would say 35 Celsius, because 35 Fahrenheit, maybe not so much. And from there, you provision it. Well, again, it's using a topic. You provision an action. So if the temperature is greater than 35, maybe we want to send out an alert via SNS. We can do that. And you do it via this pairing of rule and action. You can see the services on the right here of the slide. Kinesis, EMR, SQS. It's all the AWS services that we actually support right now, out of the box with AWS IoT. Two other things I want to touch on is republish in ML. So republish means that you can select, the temperature out of this particular device and republish it to another device's topic or to another topic altogether. It's a way of reusing it and streamlining the process if you may be performing some kind of transformation on the data. And ML being machine learning, you can perform that on this particular feature as well. So it's very, very useful from a, I'd say, routing perspective and making use of all the other AWS services that you've grown accustomed to. Now the device shadow, this is where the QoS 2 comes into play. The device shadow is it's a logical representation of state. So if you can see here, it's a JSON-based document, and we've got different attributes or fields. In this case, we've got reported and we've got desired. So, I apologize for this clicker. Reported is what the device is reporting from its actual side. So the state that's going up, that's what the device is reporting. Desired is kind of the reverse, is the application is trying to set the state of the device. So it says, you know what, I want to set the desired state to X, Y, Z. So that's what the two mean in this case. And the last bullet point says application interaction. It's because at the end of the day, you want to interact with these devices. I mean, that's the reason you're pushing the data up to the cloud. And if these devices are offline, you still want to be able to access them. This is where the device shadow comes in. And I suppose it's kind of easier to jump into an example. So you can see here on the left-hand side, we've got a fan. We've got the shadow in the middle, and we've got an application sitting on the right. So if we go through this example, there's a blue light on this fan. That means it's reporting to the shadow that it has a blue light, kind of like my shirt and my name tag. From there, the application says, well, what's the current color of the fan? So it queries the device shadow. This in turn will give it a blue as a response. But what if that application wants to set the color to red? Maybe it's a different time of year, and they say, you know what, we want to set it to red. Well, this is where number 3 and 4 come in. It sets the color to red using the desired state. As you can see the difference between desired and reported. But device is not connected, so something's going to go wrong. Actually, no. Once the device is reconnected, that desired state still propagates down to the device. And from there, if it's queried, it says, hey, my reported state is red. So that's one way to understand how device shadows can work. Ooh. I'm starting to figure out this clicker is not very, apologize. The registry. So the registry is a collection of static device metadata. What that means is something like manufacturer, type, serial number. All of this data that you're getting from the device, you can store it in the registry. And then from there, you can even group devices. You can group it with thing type. As I mentioned, the example of the light bulbs. Maybe all of the devices that are connected to floor 5 are light bulbs. This is where you do it in thing types. You can go one further and say, you know what, let's group them with the actual floor itself. So floor 5, you group everything together. And the nice thing about doing that is you can link it with what we call AWS IoT device management, which is coming up, and you can perform jobs. And a job means that you create it once, and you can run it against all those devices because you're running it against a group, versus going in, maybe running it against one device. It's a way of trying to make the platform easier to use. And that way you kind of scale your adoption and accelerate therefore. So we've talked about what we call the AWS IoT core. I mean, that's I suppose, the gist of connecting to the system. And that's where it falls in on the AWS IoT architecture. But if we shift back to the edge, We had customers come to us and say, well, I've got devices and they're not always connected. Sometimes they go underground or there's not a reliable internet connection. How do we scale that? How do we actually, use your platform? So this is where the gateway comes into play. And it's through a product we call AWS Greengrass. Essentially, we're trying to move or extend AWS IoT to the edge. And the way we do that is by allowing local messages, even triggers. So those MQTT messages that would usually go to the cloud, you can route them to a Greengrass device and be rerouted to another device. So device-device communication can happen locally. You're reducing latency. And as you go along, you can say, well, look, I want to perform maybe a local action, but I've kind of grown accustomed to using AWS Lambda. Well, you can write a Lambda function, and you can run it on Greengrass itself. So in addition to those messages, you can run these local actions. The data and state sync means that, well, usually with my devices, I'm sending the data every few seconds, maybe every few minutes. In this case, you can send the data to Greengrass, and it will offload to the cloud. And you can do that at various times of the day, maybe days of the week, maybe even months of the year. Maybe you want to keep a local sync throughout the day, but only at 5 p.m. you want to send that sync through to the cloud. This is where you do it, through Greengrass itself. It's using the same security standards, protocols that you're accustomed to by using AWS. Everything comes standard in the sense that we want to make sure that if you use the platform, it's secure by default. Local resource access, I like this feature a lot, is if your Greengrass device has a device it's connected to itself, you can actually query it or maybe utilize it. The example I like to use is, say you've got a Greengrass device sitting in a container truck. Maybe it's measuring temperature and humidity, and if it reaches a certain threshold, you want to kick in a fan. This is how you would do it. It's like if X or Y, start up the fan so that it cools down the container so that the temperature drops. Even GPIO pins, so for those who've utilized actual microcontrollers themselves, you get access to those pins and you can perform actions through that and actually query data. So as I mentioned, if you've got a different sensor that's connected to it, you can utilize it. The machine learning inference, I don't know how many people are familiar with Amazon SageMaker. It's a way of training and modeling ML workloads in the cloud, especially the AWS cloud. You can utilize those models, the same ones that you're creating, with Greengrass. And the way you do it is with inference. So essentially, you create the model, train it up in the cloud, but when you want to utilize it on the Greengrass device, you push it down and use it via a term called inference. And we support that. This is, again, out of the box. So you can start playing around with these fun features right away. I would say after the talk, maybe. Protocol adapters, again, customer feedback. We have a lot of customers who are utilizing existing, let's say, services or software that they've got in their actual factories. Maybe it's a PLC device, industrial setting. The protocol adapters are designed to actually help you move those workloads to the cloud without replacing the whole thing immediately. You put the adapter in between, and it's usually via OPC UA, and it helps you to bridge the gap to the cloud. So you don't have to redo or get rid of all your devices right away. This is the way you can actually start using them with existing industrial equipment. And OTA, or over-the-air updates. What that means is, again, for those of you who have smartphones, you usually see it says, hey, I've got an update here for my OS. That's over the air. It's done as it's quite literally saying you've sent it over the air, in this case LTE, in this case possibly Wi-Fi. And that update is streamed via MQTT. It's also got rollback, failover, so it means that if the update didn't succeed, it'll roll back. But it's a way of updating the devices without sending them back to the manufacturer to say, hey, can you update it? You can push those devices through. So, as we said, AWS Greengrass. that sits here on the edge. Now, but if we stay in the edge just for a moment, a lot of customers have come to us and said, you know what, I love the platform, Greengrass is awesome. I'm having trouble coding or decoding how to program for a microcontroller. Is there no easier way that we can get up and running? Well, this is where Amazon FreeRTOS comes in. Now, FreeRTOS stands for Free Real-Time Operating System. It's something that's existed for over 10 years. It's tried and tested. What we've done is actually created an Amazon flavor of it, Amazon FreeRTOS in this case, as we've said, and that allows you to get up and running with these microcontrollers a lot quicker than if you had done it yourselves. I mean, think about coding in embedded C versus you using an OS layer where you just have to code on top of it. And it comes with these libraries. In this case, the local connectivity. So if you have Greengrass, you can connect to Greengrass as your endpoint going to the gateway, going to the cloud. So those libraries are built in. And again, we support several devices from manufacturers like ST, NXP, and so forth. In fact, we even support the ESP32, which is a very low-cost device. It's about $11 on Amazon.com. So the cloud connectivity libraries, again, we're baking it into the product so you don't have to code it yourself. And these libraries allow you to connect to the AWS IoT core. So again, you can push your data up, but you're starting with the microcontroller. And then from there, you're building on. But as I said, out of the box, you can connect to all these fancy services that we have in our ecosystem. Same security level that you're used to, one where, we're trying to prevent any bad actors, people from doing the wrong kind of security authentication, using more than one certificate, things like that. We're trying to, let's say, not promote for customers to do, but best practices. So, for example, in general, with certificates, you should provision one per device. You should never use them across devices. It's just, it's not a good practice, because what if one device fails and you have to decommission that certificate? You're going to have to decommission it across every device that uses it. So as a best practice, try and use the one-per-one paradigm. Again, OTA and code signing, things that are in beta, is over-the-air updates, which we've mentioned, very similar process where, hey, I want to push through an update, but I don't want to have to post this device, which, could take several days, several months, depending on where you are, to actually update it or go in and plug it into an actual Ethernet port. So use OTA to your advantage, is push the updates that way. Make sure that when code signing comes in, you can do that too. So this is the microcontroller architecture that we had. And this is, like you can see, on the far left, these are the endpoints which connect to the gateway, again, going through AWS IoT core. But from there, we've kind of only talked about one-on-one devices. What if we're trying to provision multiple? And multiple, I mean, maybe 10 as a test environment, maybe 1,000 as production, maybe millions, tens of thousands. This is where you need another mechanism to actually help you do that. So again, AWS IoT device management, this allows you to maintain an actual fleet of devices, whether they be, like I said, 10,000, a million. And what it does is you essentially create a template, and from that, you can run that template against multiple devices. So whether that's 1, 2, 10,000, and it's, again, a way of mass provisioning devices without having to go in and actually click on each one and say, okay, create certificate, download, do this, do that. So this is the way we're trying to help you onboard devices as quickly as possible. And we have real-time indexes. What that means is you're actually indexing all the devices that you provisioned through the system or this service, and we're pairing it with the actual device shadows. So from there, imagine if you could just query it against there using one portal versus going in and running SQL queries in each device. So this is one way of doing it, is to do the fleet and index search, and it's a way of finding devices that maybe you didn't even know were provisioned. Maybe they were provisioned by a different office. just locating them if you've got that many devices, it kind of becomes a problem. The device logging, and this feature is also quite cool, is the fact that you can go into each device and actually change the logging level. Maybe you see something going on with the device, and you're like, well, I need to go and investigate. Let me up the logging level, but I don't want to do it for all the devices. Just go in, isolate, do it for the one. You can monitor it, and then you can change it back once you're done. But again, it gives you that kind of, narrowing of your gaze to, okay, that's the one I need to focus on. Let me make sure it's up and running correctly, and then from there, put it back into the fleet. Again, OTA updates. I'm sure this is the third time we've talked about it, so I hope it's ingrained in everyone's brains. Maybe this counts as an OTA update, because I'm giving you knowledge and updating you. So, again, fleet onboarding. This is where it comes in. The next one is audit protection. So you've got all these wonderful devices, but is there a bad actor who's messing with them? Maybe someone's changed them to kind of say, hey, this is now a botnet and we're spamming someone. Or we're trying to get information from those devices that we shouldn't be getting as someone who is a bad actor. So we want to make sure that your fleet is, well, secure, and you want to make sure that you can audit it. This is where Device Defender comes in, and you define these configurations or these audit configurations. And from there, it checks to see, okay, does this fall under policy? It does, okay, then I'm fine. If it doesn't fall under policy, then you should be doing something to change it so that it does go back under policy. The way you do that is by, well, again, monitoring the devices and using this particular service to identify and seek out those anomalies. So again, it could be something like someone's commandeered a device and it's sending out spam packets. We want to make sure that we can go in and decommission that device or reboot it or change it or figure out what's going on. This is a service you use. Again, we want to make sure that, as I mentioned earlier, you're not using the same certificate for multiple devices. So that's one of the default policies, where you're checking, okay, are you using the certificate for more than one? You are, that's a naughty developer. And then you want to change it. And you want to actually go in and say, well, look, you need to update this. This is where you do it. And how do you do it? You generate alerts. For those of you who've used CloudWatch, you know it's a similar paradigm where you get you monitor a service, you get an alert, and then you actually perform some kind of mitigating action. It's a similar thing here, where you generate those alerts, whether it's an SMS, an email, or even actually going in and changing the device's firmware via OTA. So you can patch those security vulnerabilities. And that's I'd say, it's in tandem with device or fleet management. And again, it allows you to make sure your fleet is secure and not sitting there going, you know what, I have no idea what's going on in my fleet. I deployed them and I forgot about it. From there, my time is done. And you're like, nope, we're going to make sure that you're constantly reevaluating, making sure that everything is up to par. So that's Device Defender. So, okay, there we go, Device Defender. So one of the last pieces on the slide that we can talk about is, well, you've got all this data coming in. You want to perform some kind of meaningful insights. Maybe you want to check if something's happening across floor 5. Apparently floor 5 is not good because there's light bulbs are turning off and on all the time. This is where you have AWS IoT analytics. So it's a way, again, of staying in the ecosystem, not having to pipe the data anywhere else. That being said, you set up channels. Now these channels most likely are coming from AWS IoT. However, you can pull in other data sources. If you want to pull in Kinesis, you can pull in Kinesis. If you want to use multiple streams to actually perform an analytical workload, that's fine. But you start with the channel. And from the channel, you can set up what we call a pipeline. Now, in that pipeline, you can transform data. You can filter it. You can add, subtract. The one we like to point out here is maybe you want to convert from Celsius to Fahrenheit. It's a very common use case. This is where you could do it in pipelines. And from there, it's part of your pipeline, so as data comes in, you don't care what format, it's always going to convert it correctly, and then you go from there. and it stores it in an IoT-optimized data store. The way it's stored is raw data and processed data. I mean, those are pretty cool. I think it's a case that, you know what, I want to keep the raw data in case I want to perform some kind of analysis on it later down the line, maybe historical analysis of what happened over several years. Well, I've got the raw data and the processed data where, okay, I've done all these transformations, I've changed it from Celsius to Fahrenheit. Now I can actually start querying the data, and you do that on your data sets directly. And again, you can use it with SQL as a default. Excuse me. You can use SQL to query the data sets, but we're at AWS, we're customer obsessed, so we give you more options. You can actually use Jupyter notebooks. You know, even standard templates that we've provisioned that you can utilize and add on top of. And Jupyter notebooks allow you to, again, you can perform your machine learning. You can use Amazon SageMaker to train those models and then utilize them in these Jupyter notebooks. So we're giving you all these options to use because we want to make sure that at the end of the day, you can use the platform the way you need to use it. And you know, sometimes it kind of changes, so that's why we've got the SQL built in, where you can start using it to get kind of up to speed of how to use AWS IoT analytics. And then from there, once you're really comfortable, you're like, cool, now we can get a data scientist, start using the notebooks, you know, plugging in Python or Ruby or Scala. What else is there? Go. So AWS IoT analytics. So this is the last point of that particular slide. And you can see this builds out our ecosystem from left to right, of starting at the edge with your devices, coming in, connecting, from there saying, well, I've connected one device, I want to provision several thousand, then from there I want to make sure they're all secure, and at the end of the day, I want to use that data. But there's one more thing. Oops. We have something called the AWS IoT one-click. Now, a lot of customers, again, have said, well, we can use FreeRTOS. Actually, this is pre-FreeRTOS. We can use AWS IoT Core, but we can't get connected easily. You know, we still can't. So this is where this particular feature comes in handy. It's physical buttons. You can see the top one is a Wi-Fi enabled button, and the one below is actually LTE. They come with certificates that are pre-provisioned on them. You can't change them. The one, again, as I mentioned, connects over IoT. The other one connects over LTE, and they have a certain number of clicks. So once those clicks are exhausted, sadly, the button needs to be replaced. With those clicks, you actually configure these buttons. You can do it via the app. You can do it online on the console directly. And you configure a Lambda function. And that Lambda function can do, well, whatever you want, actually. Think about it. Lambda plugs into any of the AWS services. So you could click this button, and from there go in and say, well, configuring, deploying, okay, well, what do I want to do with it? Maybe I want to turn my car on, if my car is Wi-Fi enabled. You could do it over here. And you can extract reports, because you can group these devices. Think of them as maybe you're deploying all these buttons to, again, floor 5. Each button turns on a light, so now you can say, okay, well, who's been turning the lights on and off? There's one way you could do it. Now, I will say this, right? The way I like to get people to remember that these buttons have 3 different clicks. They have a single click, they have a double click, and they have a long click, right? Is, say you're sitting at work. So maybe it's 4:10, 4:50. You're thinking, you know what, I'm going to go home. And you want to make sure that, well, I'll say wife. You make sure the wife knows that you're on your way home. You push the button once, it sends an SMS to say, hey, I'm on my way home. Maybe you're sitting there and you're like, you know what, I really want to go and get some drinks with the guys. You double click, it sends a message, you know what, I'm going out for the guys. But then, if you hold down the button, it tells you you're not coming home. So hopefully that helps you remember that the thing has 3 clicks. But let's say, look, would you like to learn more? Well, I recommend going through this AWS IoT workshop. You can take a picture. The slides are available afterwards as well. It essentially makes use of an ESP32 you connect to the AWS IoT core, and then you perform a simple workload using Lambda and SNS. So Lambda is your serverless compute option, and SNS being your notifications. So similar to the example I mentioned, you can actually go in, click a button on this ESP32, and it'll go and perform a certain action. Maybe it'll send a message. Maybe it'll send an email. It's up to you. But self-paced workshop, again, I recommend if you're trying to get up and running. Remember that ESP32 for like 12 bucks I mentioned? And one more thing I'll point out is if you want to learn how a solution comes together or how you can actually start utilizing these services to make a solution, check out this training video that we have. It's only about 10 minutes long. Essentially, it takes you through an architecture, and in the architecture, you'll see, okay, IoT is connecting here, we've got a device, we've got a dashboard, and you know what? It's hosted by this handsome gentleman. So I highly recommend it. And then from there, you can see, hey, that's a dashboard. It's got locations, so latitude, longitude, temperature, humidity. It's got a gyroscope. It's even got Alexa integration. I'm so glad to kind of be at a conference and be able to say Alexa, because in the Amazon offices, sometimes you say Alexa and all the devices just go nuts. So yeah, again, if you want to learn more, I recommend those. But you know what? I digress. So for now, I will hand off to Brent, and you'll hear from GE, because you know what? It's always fun to have a customer example.
Awesome. Thank you, Ruben. Appreciate it. Thank you. Hey, good afternoon, everybody. My name is Brent Burnell, so I lead the Edge organization at the GE Global Research Center. I want to share a journey that we've been on relative to, right, this clicker is a little tough, relative to the industrial internet. Can't do the titles page, apparently. Hey, so my job over the last 3 or 4 years has been to securely connect and software define all of GE's assets, all right? In doing that, if I use one word, it'd be making our assets smarter, right? In making them smarter, that's okay, but what really matters is what kind of action comes out, what kind of outcome comes out of that. When I put that into kind of 2 simple categories, right, I think about one outcome is changing how that asset or the thing behaves. The other is changing how I operate it, how I maintain it, how I do those other things around it. What I want to do with everybody today is focus on that changing how it behaves part, right? So if I go back to usually when I want to change how some big machine behaves, I have to think about controls, right? In controls, if you think about that, it's a discipline that's been looking down for about 230 years, right? When it looks down, it says, hey, what's happening in my machine? It uses a sensor, so it sees. It takes that sensor value and it figures out, hey, it's going too fast or too slow, something's wrong. And then it figures out what to do, think. Then it takes action, do, right? That see, think, do, how fast you do that depends on the physics of the machine, right? So you can imagine if you have something that's very, very fast, you have to do see, think, do very, very fast to be able to control it and do the things you want to do with it. If you have something that's very slow, you can take your time, do your see, think, do, and still keep it under control. What I want to show everybody was just, I want to map out how GE thinks about this. So this is actually a map of our machines. What this is looking at is, on the bottom axis, natural frequency. What's that, right? So natural frequency is every machine, every system has a natural frequency to it. Simple examples, right? I got a bell. If I have a big bell and I ding it, kind of lower frequency. I have a little bell, ding. I get higher frequency, right? So that natural frequency. So that tells you how fast things respond. I'll give you some examples. On the left-hand side is control rate. So how fast do you have to do that see, think, do, right? Let's look at one example. So on this chart, the left-hand side is slow, big. The right-hand side is usually small or electrical and fast. Okay, let's look at something on the left-hand side. All right, so a wind turbine. A wind turbine has, GE wind turbines have blades that are over 100 meters, so bigger than a football field, right? If I look at the natural frequency of those blades, it's about 1 hertz. Okay, so the general rule of thumb here is if I want to be able to see 1 hertz, Nyquist criterion says, I need to sample twice per frequency. So I need to sample twice per second. That's not so hard, right? From a controls point of view, I need to be able to see phase. Where is it exactly? To do that, I need to sample 20 times, right? Okay, so let's do some math. So if I have this big blade, bigger than a football stadium, to control it, I still need to sample 20 times faster than 1 second, right? 50 milliseconds, right? So even something as big as a football field, to control it and change how it behaves, I need to be close to it and sample that quickly, right? So I'm just trying to give people a feel for even these big, slow systems, I need to be at the edge to be able to control it and change how it behaves, okay? What that drives is, hey, I have to be deterministic at the edge. To do that, that'll keep me so I'm safe and stable at the edge. And then the things we start to worry about past safety and stability, we start to worry about security and other things going forward, right? What I want to do with everybody is share some awesome examples that we have around how we're changing how our machines behave, right? So I'm going to give 2 examples. I'm going to show you a video that's got 2 examples in it. One example is for a train trip optimizer. And the idea is that we have 2 key technologies we want to put into the edge, right? The first technology is digital twin. So digital twin is, hey, we build a model of that system. I'm going to talk about all the details. But that model is not just a model in general, on average. That model is specifically this train today on this track with this many cars. It rains, so it's this heavy, right? It's that detailed model of what is it exactly today. So that's one technology. The other technology is real-time optimizers. So now that I understand the system, I have insights to the system, now I can use a real-time optimizer to help me get the most out of that system, right? So as it sounds. And all those things I want to be able to run on the edge. And then later, I want to make sure I understand what's happening in the system, so I need to be able to get tied in the cloud. So let me walk you through that example. Okay, so nice advertisement for global research here. Okay, so first is we want to build software-defined machines, right? So I don't actually want to have things flying through the air like this, but I want to be able to have my machines be able to get updated as we learn. I want to be able to download a new app. The first thing we want to do is build this digital twin. So a digital twin is a model of the system, gets us insights to the physics, to the performance, and to the overall system. Then I take that, I put it in an optimizer. That optimizer will allow me to figure out what is the best thing to do with that system. Okay, so let me walk you through for the trip optimizer. So the model is of the train, it is of the tracks, and one of the key parts is the knuckles in between the trains. The forces in there are what matters. So what we learned is the first time we did this, we broke the knuckles, the train got stuck. Now what we do is we keep track of all the loads, we keep track of the limits, we keep track of the track conditions. We take all that model, we put it in the optimizer and say, hey, give me the best fuel flow, the lowest fuel flow, to make this trip and get there on time. We take that and we put it into our edge device. When we do that, we're getting up to 10% fuel savings. Let me think about this, right? So I didn't change the system. I just got smarter about it. I took that knowledge, put a digital twin optimizer, made an app. I take that app, I put it and run it on the train, getting 10% fuel savings, right? Massive change. Next, I want to talk about power plant. So did this with our partners in power. I think there's some people in the audience. The one here, what we're going to do is figure out what is the best way to run a power plant. In a power plant, the key thing is the blades on the turbine. Those blades can be replaced about every 3 years. We took a model of that blade, a model of the gas turbine, a model of the power plant. We played that out in the entire market and tried to figure out how to optimize profit. In doing that, we're seeing about a $1 to $2 million per year extra profit coming out of that plant, right? So just a massive change for us and our customers. If you look at that over the lifetime, it's somewhere on the order of $15 million per plant. For GE, we have around 1,000 plants, so millions times thousands. We like those dollars, right? So this is a multi-billion-dollar app, right? Changing outcomes for us and our customers, right? All those things need to run on an operating system running on the edge. We'll call Edge OS. Let me just show you that pattern keeps on working, right? We've played that same game out over, hey, transportation you saw and renewables. same kind of game. Power you saw, oil and gas. That one's interesting is that we're actually optimizing, it's a rod lift pump. That rod's a mile long, right? We're trying to figure out how to get the reduced stresses on those rod and get the most flow out of that system. By doing that, we're reducing rod stress by 20%, makes it last longer, gets us more or better flow. For our battery system, we just announced something called renewable reservoir about a month and a half or 2 months ago. Using these same kind of techniques, we're seeing we're getting about 10% better what will be revenue for that system. And then aircraft engines, we're seeing by doing the same kind of techniques and working across how you do your flight paths, about 1% reduce in fuel. We had all these things, right? Each one's a different platform, hardware platform today. We want to build an operating system that could handle these, kind of heavy, important applications, but be able to run them on a broad range of hardware. So we developed something called the Edge operating system. Hopefully it comes. So Edge OS. So Edge OS is what we're delivering to the GE businesses today. Let me just talk about some of the key elements inside of this. First is the Edge OS itself. So it's container-based, runs containers. It's running on Yocto Linux, has this controls data plane. Talk about that in a second. Has security built through the entire system. We built all our security off of TPMs. So TPMs use an IMA and building the entire chain of trust. Let me just talk about the other pieces, not the Edge OS, for just a second. All right. So first, going back to that, I want to take action. I want to change how the machine behaves, right? So we want to be able to get tied into, connected with the real-time controls. Those real-time controls can be either a separate box, or they could be another virtual machine on top of this system. So that's doing that see, think, do. It's looking down. All right. What we want to do is we can tie in a VNIC, a virtual communication path, to that real-time control. We can pull data from the sensors. We can understand what the control is thinking. Right. So now we got data into the Edge OS. Now we can run analytics. We can run digital twins. We can run real-time optimizers, machine learning, AI. All those things can run there on the edge. The key part now is we're tied back into the controls, right? So if you can get those insights that can change how the machine behaves, you can send those commands back into the controls to change how that machine behaves, just as we showed you in that trip optimizer and dispatch optimizer, right? Okay, so that's on the edge where we're running today. What we want to look at is, hey, even in all these systems where I talked about that optimizer, we talked about the digital twins, right? I need to get more information, right? So like in the dispatch optimizer, it's, hey, I really need to understand what's the weather going to be. Hey, what's the price of fuel? Hey, what's the price of electricity to be able to optimize my system? I need to pull those things in. I want to be able to look across the fleet and be able to optimize and do maintenance across the fleet. So we've been working with our AWS team. Come on, clicker, here we go. Great, so what we want to do was tie in the things that Rudy was talking about from a on-edge, be able to tie into the edge, be able to do device management on the edge, be able to do security from the cloud to the edge. So we built in AWS Greengrass. We built in the AWS device agent, right? Those things to be able to communicate and tie into all those services that Rudy was just talking about in the cloud. All right, so now I have this. It is smarter. It can change how the machine behaves. I can get to that action and that outcome. But I can also now connect into the cloud and look across my fleet and do the management across the fleet, do the health across the fleet. And then as I learn, play those back into the controls. Last part about this is just want to talk a little bit about the platform side, is that the Edge OS is lightweight, so we have it running on a Raspberry Pi, so an industrial Raspberry Pi. I'm going to talk about one example of that. You can run it on PCs, industrial PCs. You can run it on servers, right? So now you can have one operating system that works across much of your platform, right? So now it makes it a lot easier, lower cost for you to do for the overall life cycle. Okay, what I want to do is just share a couple examples. So the first one is additive. We're going to do it, I can tell. Oh, there we go, great. Okay, so with GE Additive, so first talk about additive. Additive, oh my God, what an exciting technology, right? So GE has machines that we sell into the market. We have both e-beam and laser machines. This one specifically talks about one of our laser machines. It's the M2 out of our Lichtenfeld site or in Germany. Here, the way it's set up is the baseline controls that controls the machine is built off of a Windows platform. All right, what we did was we added Edge OS. And one of the key things that that's bringing is this local analytic. That local analytic we call Meltpool SPC, Statistical Process Control. And what it's doing is it's looking at what's happening to that laser process while it's running. All right, the things we can see in there is we can see, hey, when that laser's hitting the metal, it's melting. We can look at that melt pool, the dynamics of that, and see, is it getting hot? Is it getting cold? How's it flowing? Based off of that, we can start to see what is the health of that part that we're building. Right? Today, in general in the industry, you build that part, you take it out of the machine, you heat treat that part, then you go inspect it. Right? So it's 6 weeks, 10 weeks, many months later, you find out whether that part you built was good or not. What we're doing is saying, hey, instead of waiting 10 weeks, let's go look at that and layer by layer, see if there's going to be an issue. Right? So we're moving it from 10 weeks to 10 layers because of these analytics and be able to run these things locally. Now what we're trying to do is go, okay, that's great. That's an awesome change and differentiation for our products. Now how do I get that tied into being able to look across the fleet, understand the health? So we're tying in through AWS, the Greengrass and device agent. Here's some of the pieces on the slide that's talking about what we're using. So it's IoT device manager, it's the IoT core as the initial one, S3 as the longer term storage for us, and then dashboard so that we can see what's happening across our fleet. In general, it'll be, hey, we have a site that has 80 to 100 of our machines. We want to be able to look at all of those, understand status. Everybody in the audience knows when I'm not printing, we're not making money, right? So I want to know when they're down, I want to know when they're going to be down, and I can use AWS to help us do those kind of things. Right, so just an awesome infrastructure for us to work together. I want to share with you just one more example. So this is foam wash cart. Okay, GE owns an aviation business. We make engines. We're world-class providers of aircraft engines. What happens with those engines is they essentially get dirty. When they get dirty, they lose efficiency. When you lose efficiency, that's a lot of dollars in these kind of systems, right? So what we do is we monitor those systems, and when they get to the point where the performance has degraded, we'll take, at the airport, see this wash cart on the bottom side, we'll take the wash cart, it get pulled out, and they'll actually, what they used to do is send water, spray through the engine, run and turn the engine, and that will clean off the blades and the rotating parts and the static parts inside the engine, okay? What we invented at the research center was a new foam. For the foam, what it does is, right, it's able to essentially get the detergents in their pieces so it gets more particles off. It gets it, so we get twice the efficiency improvement versus water. This is a big deal for us. It sounds like it's kind of a silly thing, right? But this is a big deal for us. Okay, so what we did was we built up a system to be able to deploy that foam in that system. Put on our Edge OS, we have the controls are running there on Edge OS on an industrial Raspberry Pi. We put in a TPM into that Raspberry Pi to get us that security root of trust at the bottom. It's got the recipe and how it's running the controls. So it's running that every time we go run one of these washes. What we want to do is, okay, while we're running, and then afterwards, be able to pull data up from that system, pull it into the cloud. We want to look at, hey, time series-wise, what was happening during that time series? Did something happen to it transiently? We want to be able to look at, use Kinesis to go look at, hey, when I did my wash, how was the performance of the engine afterwards? How much better did it get? And use that to help us to figure out, is that the best recipe of our foam? And then go back and change what the recipe is for the foam. Last part is just the dashboard analytics, so we see what's happening with our system. Right, so for us, this is just an awesome demo proof of concept for where we're going with using Edge OS and AWS to be able to look across our fleet. Right, so for me, this has just been an awesome experience. The team has been doing a great job building up all these POCs, and the capabilities we're seeing is just awesome. Okay, so I just wanted to share those examples with everybody. So, okay, last is just, hey, I I want to share just one more thing about GE Global Research with everybody. So for the past 118 years, our directive has been go make technology for the GE businesses, right? As we go forward, so we've changed our organization. We're going to change how we operate going forward. It's still going to be serve the GE businesses. That's not going to change. But going forward, it's going to be GE Global Research is going to be able to go to market. So either go to market directly or go to market with our partners. So when you think about these technologies, right now, these can be exposed to the world. And I want to find out if people are interested in learning about these technologies. So set up this link. So it's bit.ly GE-EdgeOS. So please register. Let me know if you guys are interested in these technologies and working with us as we go forward. So I think with that, we got just a couple minutes left for some questions. So.
Looks like it, eh?
Yeah, great.
Ooh, submit decision feedback. Oh, we got one. Here we go. Hello.
Thanks for a great session.
Sure.
I have a question about the GE machines.
Yep.
In addition to the AWS solutions and all the software, how impactful are changes in the actual hardware infrastructure, like cabling and specific componentry in order to deliver the data?
So for delivering the data, yeah, so at those very high speed ones, all the way down to inductance, what kind of it all matters at those very high speed ones. As you go to lower speed, it becomes less and less important. Is that kind of where we're going? Yeah, so yeah, we can talk about what kind of unique solutions we're doing at the very high speed things to get communication and controls all working. It's difficult. It takes a lot of research to get there, so yeah, 100%.
Yeah, the gentleman asked about specific hardware in addition to the AWS services that GE uses for their, yeah.
Please.
So how much of what you showed today is in production versus POC?
Yep, certainly. Yeah. So
Repeat the question too.
yep,
Yeah.
sorry. Yeah. So the question was how much what I showed was POC versus in production. I say I think every one of those digital twins, real-time optimizers, those are all in production. From the AWS peak, we're in the POC stage right now. We're testing and building for production. I'd say most of those would be in production probably first quarter next year is where we'd be going from a time scale.
Thank you.
Yep, please. Yep. Okay, one more over here. Yeah.
Oh, sorry.
Yeah, right. So we're feeding this EdgeOS technology into the digital team. So features from this will end up in their future products. So that's how we're tied together. So we're doing work for the Predicts team.
Cool. Thanks.
In the first slide, you show that all the sensors we are connecting, so we could apply the IAM rules on the sensors to protect. So would you need to make the programming on those sensors, make them secure, and manage the rules, or we have to do from the console?
So I think you're asking whether you need to use IAM rules or IAM policies right on the devices themselves. So well, not if it's just a microcontroller, because then you're securing it based on what you're coding it in. The IAM policies come into play for infrastructure users. The AWS IoT policies, those are the ones that are going to actually, at least once the device is connected, it tells you what you have access to. It's kind of two separate things you might be asking here. Is they only come into play once you're hitting the IoT system.
We are actually protecting before connecting to the cloud.
So when you
Connect any other sensor as well, when I connect it, it's going to breach the whole environment if I'm not changing the IAM group or policies on the sensor.
Mhm.
It's going to breach the connection. Any other external sensor will easily breach the whole environment if I'm not changing the IAM or group sensor or policies on the sensor level.
I think you might be misconstruing it, but essentially the certificates are the way that you're authenticating and authorizing to get to the AWS IoT service. And that's the one that you're doing. If you add another sensor, you could add them, as many sensors as you want. If you don't put it in the payload, it's not going to go through. Yeah. So it's up to you. It's your discretion. Yeah. Cool. I think we. Oh,
Yep.
one more there. Yeah, I think the slides will be up. I'm not sure of the slides themselves, but the video will definitely be up on the AWS channel. These slides are usually paired with like something like SlideShare. Yeah. Cool.
We're done.
Cool. Thank you.
Okay, thank you, everybody.